Okay, 2025 AMC 12A problem 8. Pentagon ABCDE is inscribed in a circle with angle BEC is equal to CED is equal to 30 degrees. AC and BD intersect at point F, and suppose that AB is 9. So I'm just going to label that, and AD is 24. What is BF? So we want to find BF here. I went ahead and drew the figure so we don't have to spend extra time drawing the figure. But to draw, I'd suggest starting with the circle, then starting with the angle, leaving out the A until the end. Because if you draw the A, if you try to draw the pentagon first, that's going to be a little harder. And so I just suggest always drawing out with a big circle if we have a big circle. And speaking of BEC equals CED, I'll draw in this sort of point, this line here. And so we know that these angles are equal. BEC is 30 degrees, CED is also 30 degrees. Now, looking as we have angles here, and there's not really a clear way to relate it to sides, I'm thinking of some sort of like law of cosines, law of sines to solve it. But before we can get there, we need some more angles. So let's try to get angle chasing. And another thing is just recognizing patterns, is seeing we have 5 points that are all on a circle, concyclic. We can see that we can choose any 4 of them and get a cyclic quadrilateral. And this helps us figure out a lot of angles really fast. So I'm just going to look at ABCE first. We have this is 30 degrees, so this one is also 30 degrees by cyclic quadrilaterals. And that seems just about the most we can get from that one. So now let's look at EACD. We know that this is 30 degrees. So we also know that this is 30 degrees again, because both of them subtend this sort of CD arc. And similarly here, both of them subtend to this sort of BC arc. We have this is 30 degrees, we have this is 30 degrees. Let's look at one more. Let's look at ABDE. And so from ABDE, we have, let's see, it's actually not a ton. This one is 60 degrees here from ABDE, so it subtends this sort of BD arc. Let's see what else subtends this BD arc other than this angle. We get that this angle also subtends this BD arc, and we already figured that out. That's 30, 30, that's also 60. So that's about the most angles we can get without going too much in detail. And so now let's just look at the figure and see what we have. We have this triangle ABD here, and that's really key, I think, because now we can use law of cosines to find BD, and since it's also angle bisector here, AF is an angle bisector, if we find BD, we can use angle bisector theorem to find BF, and that's what we want to find. So I'm just going to draw this triangle ABD here separately. So we have A, B, and then D. This looks something like that. D, A, B. We have this angle bisector. We know this is 30. We know this is 30. We know this is 9. This is 24. And so let's just use law of cosines to find BD. So we're going to know that 9 squared plus 24 squared minus 2 times 9 times 24 times cosine of 60 degrees is going to be equal to BD squared. So let's just solve this. Or before solving this, I'll just take out a factor of 3 from everything. Let's just like scale down everything by 3, because that would give us easier numbers. So yeah, let's scale down everything by 3. So let's turn this into an 8 and a 3, because that makes everything a lot easier. And then we can scale up by a factor of 3 again. And so I just really don't want to do like 9 times 2 times 9 times 24 and do all of that and try to find the square root. So I'm just going to erase all this and write this scaled down version. So we get 9 plus 64 minus 2 times 3 times 8. 2 times, that's just 48, times cosine 60 is equal to BD squared. So 9 plus 64, 73 minus 48 cosine 60. So let's see, cosine 60 is going to be 1/2, so minus 48 cosine 60 is 24. It's equal to BD squared. 73 minus 24 is going to equal 49 equals BD squared. And that actually worked out nicely since BD is now equal to 7. So we now found that BD is equal to 7, or when we scale up, it's going to equal to 21. But let's save scaling up till the end. And I'll just write 1/3 scale here, just so we don't forget. And now we have this, so let's just use angle bisector theorem to find BF. So we know that this is going to be in proportion to 3 over 11. This is going to be 8 over 11, since this is going to be proportionate to this. This is going to be proportionate to this. So that's 3 over 11, this is 8 over 11. So 3 over 11 times the total length, 7, gives us 21 over 11. And notice that 21 over 11 is not an answer choice because I have to go back. Since this is 1/3 scale, I have to multiply by 3. So multiplying 21 over 11 by 3 gets us 63 over 11, which is our answer. In the end, it's a cool geometry problem, but I think it's maybe a little bit harder than its position indicates at number 8. But by using quadrilateral, cyclic quadrilateral law of cosines, we were able to get it.